Another way to solve systems is to use matrices. A matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns that is interpreted and manipulated in certain prescribed ways. A system of equations can be written as a matrix. The augmented matrix of a system is derived from the coefficients and constant terms of the linear equations, each written in standard form, with the constant terms to the right of the equal signs. If the column of constant terms is not included, the matrix reduces to that of the coefficient matrix of the system. So if you take a look right here at the systems of equations, notice everything goes from x, y, z, and after the equal sign is our constant. Your augmented matrix takes the coefficients in front. So we take the 5 that's in front of the x, that goes first, the -5 in front of the y goes second, and the -5 in front of the z goes third. And then the number after the equal sign, that's our constant, it goes at the end. Similarly to the second equation, we start with our x's, the -1 coefficient goes first, the 2 for the y goes second, and the -3 for the z goes third, with our constant at the end. Now the difference between an augmented matrix and a coefficient matrix is the coefficient matrix doesn't have these constants that come after the equal sign in it. Now if we go and scroll up a little bit, we have a matrix in row-echelon form. In row-echelon form, there are 3 conditions that need to be met. Number 1, rows consisting entirely of zeros, if any, are the very last row. So if you take a look at our matrix right here, you can see there's a row of all zeros. All those zeros need to be at the bottom. Number 2, the first non-zero entry in a row is 1, and that's called a leading one. So if we take a look at the first row, 1 is the first one. In the second one, it starts with a 0, so the first non-zero entry is a 1. In the third row, we have a 0, and then again, the first non-zero entry is a 1. The third thing, for 2 successive rows with non-zero entries, the leading one in the higher row is farther to the left than the leading one in the lower row. So if we take a look over here, in our third row, we have 2 zeros and then a 1. As we go to the one above it, notice that this 1 is just to the left of the one below it, and this 1 is just to the left of the one below it. So it makes kind of that diagonal line as they move up. In example 3, not example 1. In example 3, we want to identify which matrices are in row-echelon form. So if we take a look at letter A, we have 3 things that it needs to follow. If there's a row of all zeros, it needs to be at the bottom. Well, there isn't a row of all zeros, so the first one is taken care of. Then we need to make sure the first non-zero entry in a row is 1. So if I look at my first row, my first number is a 1. The second row goes 0 and then 1. So my first non-zero entry in that row is 1. So we're set with the second thing. And then for number 3, for 2 successive rows, we need the number 1 to be to the left of it. So if we look at this bottom row, right above it, that's to the left. So we know that this is in row-echelon form, so we can say yes. In part B, if we check everything that we need to check, we look for our row of all zeros, and that is at the bottom. So the first thing is checked off. Then we need the first non-zero number to be a 1. So that checks out here. If we look in the second row, the first non-zero number is a 1. If we look in this third row, the same thing happens, and the fourth row is all zeros. So that's fine. And then we need to make sure that the ones above are to the left. So we have this one is to the left of that one, and this one is to the left of that one. So this is also in row-echelon form, so we can say yes. In letter C, there are no rows of all zeros, so we don't have to worry about the first one. The second one, the first non-zero entry in each row has to be a 1, and that's the case here, here, and here. And then the third one says that the one above has to be slightly to the left. Well, if we look at the bottom row, that's 1, and this one is directly above it. This is why it doesn't work, because this top one has to be to the left. It would have to be over here for it to be in row-echelon form. So the answer here is no. Now what I'd like you to do is take a look at the try this and see if you can figure out whether these are in row-echelon form or not and the reason why. Go ahead and pause it and unpause it when you're ready to check your answer. If you did letter A correctly, you should have said no, and the reason for that is because our row of all zeros is not last. And letter B, you should have said yes. If you have any questions on this, please raise your hand and I'll come around and help.